Assalamualaikum and selamat sejahtera. Today we will learn about Business Mathematics, Chapter 1, Fundamental Concepts of Mathematics. So under this chapter, we will learn the topic sequence, which is Arithmetic sequence and Geometric sequence. So what is sequence? Sequence is a list of things that usually numbered that are in order. So this is an example of sequence 3, 5, 7, 9 and 3 dotted point here. So 3 dotted point here means that goes on forever. So which is this is infinite sequence. So 3 is our first term, 5 second term, 7 third term and 9 fourth term. Actually term, element or member have the same meanings. Okay, infinite or finite. So what is the difference between finite or finite sequence? So infinite sequence is the sequence that goes on forever, which is the sequence has 3 dotted points on the sequence. So example of infinite sequence is 1, 2, 3, 4 and 3 dotted points at the end of the sequence follow. Same as second example 20, 25, 30, 35 and they have also 3 dotted points here means this is infinite sequence. While our third and fourth example 1, 3, 5, 7, 4, 3, 2, 1. So they have no 3 dotted point at the end of the sequence. So it means this example is example for finite sequence. Fibonacci sequence. So this is example for Fibonacci sequence 0, 1, 1, 2, 3, 5, 8, 13, 21 and 34. So what is Fibonacci sequence? Fibonacci sequence is actually the number that is found by adding the two numbers before it together. For example, in order to get our third term here, we need to add up first term plus with term, second term. So when we add the summation of our first and second term, 0 plus 1, then we will get 1 here. Okay. Same goes if we want to find our fourth term, we need to add up our second term plus the third term, then 1 plus 1, we will get 2 here. So the rule for Fibonacci sequence is Tn equal to Tn minus 1 plus Tn minus 2. So this is the table rules that are like recursive formula for Fibonacci sequence. A sequence actually has a role. We look at this example 3, 5, 7 and 9. If we look at this example, it's like we start at 3 and jumps to every time because the common difference between our first and second term, our second and third term and so on is 2 here. So in order to solve our next term until infinite term is difficult to us to use this word start at 3 and jumps to every time. So we want a formula with n in it, where n is n term number. So what a rule that we can use for this example of sequence? Okay, so let me try an error by using this dash rule to n. So we come up with this table, which is n is our first column, 1, 2, 3, and term is the sequence in this example, 3, 5, 7, and so on. So let me use our n and term by using this dash rule to get the value for this sequence. So let our n is equal to 1. So when we substitute n equal to 1, then we will get 2 times 1 equal to 2. While when we substitute n equal to 2, then we will get 2 times 2 equal to 4. And when we substitute n equal to 3, then we will get 2 times 3 equal to 6 here. So if we look at this value 2, 4, and 6 not synchronous with our sequence 3, 5, and 7 because the value 2, 4, and 6 is low by 1 every time. Hence, we try by using our next test value, test rule, which is 2n plus 1 because our previous is low 1 every time. So our first and second column we use is same with our previous example. So let we test this rule one by one. So when our n equal to 1, we just replace the value of n equal to 1 here. Then we get 2 times 1 plus 1 equal to 3. And when we replace n equal to 2, then we will get 2 times 2 plus 1 equal to 5. When our n equal to 3, then we will get 2 times 3 plus 1 equal to 7. So if we look at this answer, 3, 5, and 7, it is same with our sequence here, which is the term is 3, 5, and 7. So we can use this rule to this sequence. That's works. Okay, so instead that we use the words start at 3 and jumps to every time, we can write this rule to this sequence, which is 2n plus 1. Okay, so this is arithmetic sequence. What is the arithmetic sequence? Arithmetic sequence is actually the difference between one term and the next is a constant. So what is a constant here means a constant is a difference between second term and first term must be same with the difference with third term and second term and so on. So the important general term that we need to know in arithmetic sequence is first our first term. Okay, our first term we call it as A. Then followed by the common difference is D and T and is n term. So the first term T1 equals to A, the second term T2 equal to A plus D. Then our third term T3 equal to A plus 2D and our fourth term T4 equal to A plus 3D. So let we look at this example 1, 4, 7, 10, 13, 16, 19, 22 and 25. So this sequence has a difference of 3. How we get 3 here? We just minus our second term with first term. 4 minus 1 equal to 3, or we can use our third term minus with second term. 7 minus 4, so we get 3 here. Then we can use the rule T n equal to 3n minus 2. So in general, we can write the arithmetic sequence like A plus D, A plus 2D, and A plus 3D. Okay, so we can come up with this rule to find the followed term, which is Tn equal to A plus D times n minus 1. So we need to times with D plus n minus 1 here because our first term didn't have any D at our first term. So this is next example to calculate the fourth term for the given sequence. So we have a sequence 3, 8, 13, 18, 23, 28, 33, and 38. So the first thing when we want to solve for sequence arithmetic sequence, so we need to identify our first term first. So our first term here is A equal to 3, then followed by D. So we need to identify our common difference. So what is the common difference? Common difference is the difference between our second and first term. Okay, so we find T2 minus with T1. So we get 8 minus 3 equal to 5. So we declare first our A equal to 3, our D equal to 5. Then we just use the rule Tn equal to A plus D times n minus 1 here. So when we replace the value of A equal to 3, D equal to 5, then we just substitute and expand row, then we will get Tn equal to 5n minus 2. So in this question, we want to find the fourth term here. So we just multiply or replace the value of n with 4. Then we will get 5 times 4 minus 2 equal to 18. Okay, look at example 1 here. We want to find the 50th term in the arithmetic of sequence 3, 7, 11, and 15. So this sequence has a difference of 4 between each pair. How to get 4 here? We will find the common difference by minus our second term minus third term. So 7 minus 3, then we will get 4 as our common difference. So as usual, when we get the question, we need to identify what is our A, our first term, and what is our D, our common difference. So from here, we will get our A equal to 3, and our common difference here is equal to 4. Okay, so we will use the rule for Tn is equal to A plus D times n minus 1. Hence, we already know the value of A and D. We just replace into this formula, which is our A equal to 3 and our D equal to 4. Then we expand the bracket and solve for it. Then we will get Tn equal to 4n minus 1. So this question wants to find the 50th term. So how to find 50th term? So 4 times 50 minus 1. So this is equal to 200 minus 1. So the answer for 50th term is 199. So example 1, the answer is C, 199. In this question, for example 2, we want to find the 20th term of the arithmetic sequence for 21, 18, 15, and 12. So first of all, as usual, we need to identify what is our first term and what is our common difference. So from here, we know our first term is 21, while our common difference is equal to our second term minus with our first term. So 18 minus 21 is equal to negative 3. So negative 3 here means is a common difference. Okay, so the value of common difference, it doesn't matter whether it's positive or negative value. Just take the symbol of positive and negative together. Okay, so as usual, we will use the formula for Tn is equal to A plus D times n minus 1. And then we just replace the value of A, which is equal to 21, and the value of D, negative 3. Then we solve for it, we will get Tn equal to 24 minus 3n. So we want to find the 20th term. So we just replace the value of n here with 20. Then we will get T20 equal to 24 minus 60, which is T20 equal to negative 36. So the answer for example 2 is B, negative 36. Okay. This example want to find the first term of an arithmetic sequence is 4, then the 10th term is 67. So we want to find the common difference here. So that we use the formula for Tn, which is Tn equal to A plus D times n minus 1. So from the first statement here, we already know the value of A equal to 4. So that we put it as equation 1. Then our second statement here, we already know our 10th term is equal to 67. So T10 is equal to A plus B times 10 minus 1, which is equal to 67. So let me put it as our equation 2. Then we substitute A equal to 4 into our equation 2 here. Then we will get 4 plus 9D equal to 57. Then 9D equal to 63. Then we will get D equal to 7. So the answer for this example, which is the common difference, is 7B. Okay, so this example 4, we want to find the 32nd term of the arithmetic sequence negative 12, negative 7, negative 2, and 3. So this sequence has a difference of 5 between each pair of number. So 5 is the common difference. Then the first term is negative 12. So the rule can be calculated by using P5 equal to A plus D times N minus 1. We just replace the value of A equal to negative 12 plus with D is equal to 5. Then when we simplify this, we will get T5 equal to 5 and minus 17. So the 20th term is T32 is equal to 5 times 32 minus 17. So T32 is equal to 140 function. So this is the formula how we get the summation of arithmetic function. Let's say we have our first term A, second term A plus D, third term A plus 2D, followed by the third term A plus 3D. Then there is the sigma notation here, which is at the top of the sigma is n equal to 1, and at the bottom of the sigma is k equal to 0. If we add up all these series, then we will get A plus KD, which is equal to negative 2A plus N minus 1D. So this is, we call it as a sigma or summation up. So example, if we have summation for N, okay, so 4 at the top is the value, summation for how many sequence, starting value at N minus 1. So what is the sum? How to get the value of sum here? We just add all the number here, 1 plus 2 plus 3 plus 4, then we will get the summation of n minus 1 to 4 is equal to 10. Okay, so how we get the formula for arithmetic function for arithmetic sequence is, the first of all, if we sum all of the sequence in arithmetic function, so we will get S equal to A plus D plus at the end plus A plus N minus 1D, and followed by S equal to K. So if we revise our first equation here, we put the last sequence for the first one and our first term to be our last sequence here. So it will become like this in our second equation. So when we add up first equation and our second equation, so it becomes like that. Okay, 2s equal to 2a plus n minus 1 times d. So if we look at here, every single summation here like same. Okay, same value. We will get the same value here. So if we summarize from this, we will get 2s equal to n times 2a plus n minus 1 times d. So if we want only s as our subject, so we need to divide all the terms here by 2, so that we will get our subject s. S is the summation for arithmetic sequence is equal to n over 2 times 2a plus n minus 1 times d. Okay, so this is example for arithmetic sequence 1, 4, 7, 10, 13. So a equal to 1, our common difference is equal to second common difference minus first 4 minus 1, then we will get 3 here. And we want to find the summation for the first 10 terms, so n equal to 10. Okay, so a plus kd, summation of n minus 1 for k equal to 0. So when we substitute the value of n equal to 10 here, k, we didn't know, k, a is 1, 3, 4, d. Okay, so k is equal to n minus 1 actually. So it's become like that. Then we can calculate and get the solution. Okay, look at example 6 here. We want to find the sum of the first 16 term of arithmetic sequence 1, 5, 9 and 13. So how to do it? Let we do one by one. So first we need to identify our A. First term is equal to 1. Our common difference D. okay, which is our second term minus with the first term. So 5 minus 1 equal to 4, and n is equal to the first sums of 16 terms, so n equal to 16 here. So by using the formula as n equal to n over 2 times 2a plus n minus 1 times d, we just substitute the value for n, a, n, and d that we have found previously. Then we solve and expand the bracket like this. So we will get at the end as 16 is equal to 496. So the answer for example 6 is B, 496. Okay, so let me look at example 7 here. We want to find the sum for the first 30 terms of arithmetic sequence, 50, 45, 40, and 35. Okay, so we do one by one. We find our A first. So A is equal to 50, which is the first term. So D equal to negative 5, second term minus the first term, 45 minus 50, then we will get negative 5 here. So N equal to 30 because of we want to find the summation for the first 30 term. So by using the formula as n equal to n over 2 times 2a times n minus 1d, then we just substitute the value of n that we have found previously, n equal to 30, a equal to 50, okay, n minus 1, 50 minus 1. So 50 minus 1, 30 minus 1 equal to 29 times with d negative 5 here. Okay, then we calculate, we expand all the brackets here, then we will get as 30 equal to negative 675. So the answer for example 7 is A, negative 675. Okay, next example, we want to find the sum of the 11 to 20 term. Okay, so let we do one by one. Our A is equal to 7, our D is equal to 5, our second term 12 minus 7, then we get common difference is 5 here. Okay, so in order to find the summation for the 11 and 20 term, so we need to try by one by one. So let we try to solve for S10 first. Okay, we solve for S10 when we substitute the value of n equal to 10 here, A equal to 7 and D equal to 5, then we will get our S10 equal to 295. Okay, then we find for the S20. Okay, how to find S20? We just substitute the value of n equal to 20, A equal to 7, D equal to 5, then we solve for the bracket, then we will get S20 is equal to 1090. Okay, therefore the sum of the 11 to 20 term is equal to 1090 minus 295. Then we will get the summation of the 11 to 20 terms is 795, which is C. Okay, example 9, we want to find the 11 terms of arithmetic sequence is 30 and the sum of the first 11 term is 55. So our first equation, let we find for the term first. So remember our previous example, we have find Tn equal to A plus D times n minus 1. But the formula for summation is Sn equal to n over 2 times 2a plus n minus 1 times d. So let we find for our first equation first, which is T11 equal to a plus d 11 minus 1. Then we solve for it, we will get a plus then d equal to 30. Okay, this is our first equation. Then we compute for our second equation. So our second equation we already given here. The sum for the first 11 is 55. So means S11 is equal to 55. So 55 equal to 11 over 2 times 2a plus 11 minus 1 times d. So at the end we solve it, open the bracket, expand in the bracket, then we will get a plus 5d equal to 5 here. Okay, in order to solve this both equation, we will use the elimination or substitution equation. Okay, so for this case, we will subtract equation 2 into equation 1. So we use elimination method here. So a minus a is equal to 0, 10d minus 5d equal to 5d. So 30 minus 5 equal to 25. So we will get d equal to 5. So the answer for example 9 is a equal to 5. So what is geometric sequence? Geometric sequence is each term is found by multiplying the previous term by a constant. So let's say we have an example of geometric sequence 2, 4, 8, 16, 32, 64, 128, 256. Then the rule for this term is Tn equal to 2 to the power of n. So in general, we can write the geometric sequence is AR to the power of 2, AR to the power of 3. So our first term is A. Our common ratio is R. How to get the common ratio? Our second term divided by first term, or our third term divided by our second term. We should be noted here R should not be equal to 0, because when R equal to 0, we get the sequence of A, 0 and 0, which is not a geometric sequence. So this is example of geometric sequence. We have 10, 30, 90, 270, 810, 2130, which is our A equal to 10, R equal to 3. So by using the rule of Tn, so you get 10 times 3 to the power of n minus 1. So if we want to find the fourth term here, we just replace the value of n equal to 4. Then we solve for it, we will get 10 times 3 to the power of 3 is equal to 270. So if we want to find 10th term here, we just replace the value of 4 previously with 10, because we want to find the 10th term. So T10 is equal to 10 times 3 to the power of 9, which is the answer is 196,830. Okay, so the term in geometric sequence is Tn equal to AR to the power of n minus 1. We use n minus 1 here because for our first term, if we substitute the value of 1, n equal to 1, we will get AR to the power of 0. Our power of 0 is 1, then we will get the value for our first term is A. So let we have an example of geometric sequence 1, 2, 4 and 8. So our first term here is 1, our common ratio here is 2. So we will get the sequence like this: AR to the power of 2 and followed by AR to the power of 3. So when we replace our A is equal to 1 and our R is equal to 2, then we solve for it one by one, then we will get the sequence is 1, 2, 4 and 8, like our given example here. So we need also to notify here that geometric sequence also can have a smaller and smaller values like this: 4, 2, 1, 0.5 and 0.25 and so on. So the common ratio here is 0.5. How we get 0.5? Our second term divided by our first term. 2 divided by 4, then we will get 0.5. So the rule for Tn is equal to 4 times 0.5 times power of n minus 1. So look at example 10 here. We want to identify our 11th term for the geometric sequence 3, 6, 12 and 24. So we know here the value of A is equal to 3, the value of R is equal to 2, which is R given T2 divided by T1, 6 divided by 3, then we will get 2 here. So the rules of any term we know to n equal to AR to the power of n minus 1. So T11, we just replace all the value in this formula. So T11 is equal to 3 times 2 to the power of 10. So we solve for it, we will get T11 is equal to 3072. So example 11, we want to find the 9th term of the geometry 81, 27, 9 and 3. So we know already here the value of A is equal to 81, the value of R is equal to 1 over 3. So we also use the rule Tn equal to AR to the power of n minus 1. Therefore T9 is equal to 81 times 1 over 3 to the power of 8. We solve for it when we will get T9 equal to 1 over 81. So the answer for example 11 is B, 1 over 81. So we want to find the first term of a geometric sequence is 5 and their sixth term is 160. So the question is what is the common ratio here? So we know A equal to 5, Y the sixth term is 160. So T6 is equal to AR to the power of 5, which is 160. So when we substitute the value of A equal to 5 into our equation here, then we will get 5R to the power of 5 is equal to 160. Then R to the power of 5 equal to 32. So we solve for it, we will get R equal to 2. So answer for example 12, the common ratio is B2. Okay, so here we want to find the first term. If we are given the fourth term of geometric sequence is 27 and the seventh term is 1. So T4 is equal to 27 means AR to the power of 3 equal to 27, AR to the power of 6 equal to 1. So we have two equations here. So by dividing equation 2 from equation 1, we will get R to the power of 3 is equal to 1 over 27. Then we solve for it, we will get R equal to 1 over 3. So substitute R equal to over 3 into equation 1. Then we solve, we will get A equal to 729. So the answer for example 13 is B, 729. Okay, so this is how we find the formula for summation of geometric sequence. Okay, summation of geometric sequence is actually A plus AR to the power of 2 and so on until the end of the sequence is AR to the power of n minus 1. So let we multiply the first equation by R, then we get SR is equal to AR plus at the end of the equation is AR power of n. So let me put it as equation 2 here. So if we add up these two equations, equation 1 and equation 2, then we will get like this. Okay. We subtract equation 1, we subtract with equation 2. So S minus S times R is equal to A minus A R power of n. At the center, we will reduce all this because we have the same value. When we minus, it will less, it reduce. Okay, so from here we summarize. Here we factorize this function. So we will get S bracket times 1 minus R equal to A 1 minus R to the power of n. So we solve for the value of S equal to A 1 minus R to the power of n over 1 minus R here. Okay, so that we put the summation notation here, which is sigma n minus 1 to k equal to 0 for AR to the power of k is equal to A times 1 minus R to the power of n over 1 minus R. This one for R less than 0. Okay, so for R, when R is less than 0, then we use this formula A 1 over 1 minus R. Okay, so summation for the geometric sequence actually that we sum up all the sequence that we have in the geometric sequence. So the formula for summation of geometric sequence is A 1 minus R to the power of n over 1 minus R. Which is A is the first term, R is the common ratio, and n is the number of the term. So R must be between -1 and 1. Okay. So R should not be 0 because when R equal to 0, we will get A0, 0, which is not geometric sequence. So this example, if we have 1 over 2, 1 over 4, 1 over 8, 1 over 16, so we know our A is equal to 1 over 2, our R is equal to 1 over 2 also. Then we substitute all the information here, then we will get the summation of this sequence, geometric sequence, is equal to 1, which is equals exactly to 1. Okay, so this example, we want to find the first 5 terms, the summation of the first 5 terms. So we know the A equal to 10 or equal to 3 by divide second term with first term. Then we know we want to find N for first 4 terms. So we use the formula A times 1 minus R to the power of N over 1 minus R. So 1 minus 3 to the power of 4 over 1 minus 3. So that we will get 400 here. But if we use the manual calculation, 10 plus 30 plus 90 plus 270, then we will get 400 here. Okay, this is an example of application geometric sequence in real life. Okay, so next is example 14. We want to find the sum of the first 8 terms of the geometric sequence for 5, 15, and 45. So our first term A equal to 5, our common ratio R equal to 3, our N equal to 8. Since we want to find Sn here, so S8 is equal to 5 times 3 to the power of 8 minus 1 over 3 minus 1. Then we solve for it, we will get our S8 is equal to 16,400. So the answer for example 14 is 16,400. Okay, so next we want to find the 9th term of the geometric sequence. We already given A equal to 1 over 3, then R equal to negative 1 over 3. Okay, by using the formula of N equal to A1 over 1 minus R, because our R is less than 1, less than 0. Okay, so we just replace all the information that we have here, then we calculate, we get S9 equal to 1 over 4. So the answer for example 15 is 1 over 4. Okay, next we want to find the summation. What is the summation for the first 9 terms? We have our first term equal to 20, R equal to 1 over 2, and equal to 9. So we use the formula Sn equal to A times 1 minus R to the power of N over 1 minus R. Okay, so S9 is equal to 20 times 1 minus 1 over 2 power of 9 over 1 minus 1 over 2. Then we solve for it, we will get S9 equal to 39.96. This question want to correct to 1 decimal place. So the answer for example 16 is A, 39.9. So simple interest and introduction to interest. So what is actually interest? Interest is how much is paid for the use of money, let's say in terms of percent or an amount. So money is not for free to borrow. People can always find a use for money, so it costs to borrow money. So how much does it cost to borrow money? Different places actually charge with the different amount at different times. So but they usually charge by using this way as a percent per year of the amount borrowed. So it is called as interest. So example, I may borrow 1,000 from the bank and I may want to borrow 1,000. The local bank said 10% interest. So to borrow 1,000 for 1 year will cost 1,000 times 10%, which is equal to 100. So in this case, the interest is 100, then interest rate is 10%. So let's say today I may borrow from bank 1,000. So next year I may need to pay to bank 1,000 that he has borrowed plus with 100 interest. So I may borrow 1,000, but he has to pay back 1,100. Okay, so what we use here, 1000 is the principal. Principal means the amount that Amir have borrowed. So Amir is the borrower. Ben who give the borrower, we call it as lender. So next year when the repayment process is settled, so 100 need to plus, which is called is interest. So Amir is the borrower, the bank is the lender, the principal of the loan is 1000, then the interest is 100. So the important part of the word interest is the intermeaning between. So we see intermeaning words like interior and interval because the interest happens between the start and end of the loan. Okay, example, Amir borrow 1000 today for 5 years at 10% simple interest. So the interest that Amir need to settle is 1000 times 10% times 5, we will get 500. So plus the principal of 1000 means Amir needs to pay 1500 after 5 years. Okay, next example, Amir borrow 1000 for 7 years at 6% simple interest. So interest that Amir need to pay is 1000 times 10% times 7 years, which is 420. So plus the principal of 1000 means Amir needs to pay 1420 after 7 years. So the formula for simple interest is I equal to PRT. So I is the interest, P is the amount that borrow, which is also we call it as principal, R is the interest rate, and T is the time. So example, Ila want to borrow 3000 for 4 years at 5% interest rate. So how much the interest is that? So I equal to PRT. So P is equal to 3000 times with 5% times with 4 years. So we will get I equal to 600 here. So example 70, Jerry borrow 4000 for 5 years at 6% simple interest. So how much interest? So by using the formula I equal to PRT, which is I interest, P is principal, R is interest rate, and T is time. We just substitute all the information that we have here. So P 4000 times R equal to 0.06 times T 5. Then we will get the interest is 1200. So the answer for example 17 is CRM at 1200. Okay, so next example, Jerry want to borrow 7,000 at a simple interest rate of 3% per year. After a certain number of years, he paid 840 in interest altogether. So how many years was? So by using the formula I equal to PRT, so I is 840. Principal is 7,000, interest rate is 0.03, so we didn't know the time that Jerry borrowed. So by using the formula I equal to PRTI, we already know I is 840, the principal is 7,000, the R is 0.03 times T, so we simplify it, then we will get T equal to 4. So the times that Jerry borrowed from this institution is 4. So the answer for example 18 is 4 years. Okay, next example, Sam borrowed 4,500 for 2 years and had to pay 630. So in this example, we want to find the simple interest at the end of the time. So what rate of interest that he pays? So we use the same formula I equal to PRT with the interest of 630. So the principal is 4,500. Okay, the time is 2 years. So we didn't know the interest rate here. So we just substitute into the formula I equal to PRT. So I is 630. P equal to 4,500. R we didn't know. Years is 2. So we will simplify this and we will get R equal to 0.07. Please change the decimal place in terms of percent, because basically interest will give us in terms of percent, so R equal to 7%. So the answer for example 19 is 7%. Okay, next, Julie want to borrow 3,500 for 3 years at 7.5% annual simple interest. So how much interest is that? So by using formula I equal to PRT, which is given P equal to 350, R equal to 0.075, T equal to 3 years. Therefore, we get I equal to 3,500 times 0.075 times 3, which is equal to 797.90.50. So, example 22, Dan wants to borrow 2,000 for 6 months at 12% annual simple interest rate. How much interest is that? So we will use the same formula, which is I equal to PRT. So the value of principal T is equal to 2,000, interest rate is equal to 0.12, and time equal to 6 months equal to 0.5 years. So I equal to PRT, we get the interest here is equal to 120. So the answer for example 21 is 128. Okay, with that,